So I'll start from the beginning with patterns, and anything that you've already been there for in class, you can just skip on. We're going to just have a look at an overview of what you're hoping to be doing. When you see a sequence of shapes or a sequence of numbers, you're generally just looking for a pattern. Your brain will naturally try and do that, and so we're mostly going to be focused on number patterns, but don't be surprised in your Leaving Cert if you see shape patterns, but within the shapes there should be number patterns. So I'll run through some examples later on of that when we get to the end maybe. So we'll start with number patterns, and you have 4 eventually that you'll be looking at. So linear, also known as arithmetic. That's one type. You have geometric. That's another type. Quadratic. And cubic. So we're going to go into a good bit of detail on these 4 different types. And the first one that we're going to start with is linear or arithmetic. This one can maybe also be called exponential, just in case. I don't know how to spell it. I think that's right. So first one we're going to do is linear. So when you have a linear pattern, you would see this. Now, when you get a pattern first, you're not going to know which one of these 4 it is. So step 1 is always going to be to check which type it is. So to recognize a linear pattern, you're going to look for a common difference. Linear, if I graphed it, would look like a line. And again, I'll show you at that, at a later stage, something like that. But that kind of makes this topic linked to functions because we have linear functions. It could also link to a little bit to coordinate geometry, because in coordinate geometry you graph lines. So this will link to loads of other topics. But how you mostly basically recognize it is we're looking for a common difference. So see the way the 7s are common, and that I got it by subtraction. I subtracted the 32 and the 25. I subtracted 18 from 25. I subtracted 11 from 18, and so on. So it's a common, and we use the word difference because it's subtraction. Okay? So I recognize it by finding a common difference. So now, once you know the common difference, you can obviously get the next part of the sequence, no problem. But eventually, I might ask you, what's the 100th term? What's the 995th term? And if that happens, you cannot spend all your time in the exam trying to figure out what that term is just by keeping on adding 7. If you're stuck and you have time in the exam, you could do that. But you're not going to do that in the exam every single time you get a pattern, because it's a waste of time. So there must be a faster way to do it. So I'll come back to this one. If we look at this one, 2, 4, 6, 8, 10, and so on. If I ask you this one, right, so that's the first one, that's the second, that's the third, that's the fourth, that's the 5th. What's the 20th? Well, you can actually see that, it definitely has a common difference of 2. But is there a fast rule that your brain would naturally come up with? Well, you just seem to multiply by 2. So if it's the first term, you multiply, the first term 1 by 2. So that's 2. If it was a second term, you double it. If it's a third term, you double the 3. If it's the 4th term, you double the 4. If it's the 5th term, you double the 5. So if I asked you for the 100th term, you double 100. So that's 200. So we want those general fast rules. So it's a very general way of coming up with a fast way to get any term that I want. So because we're talking about any term that you want, we're going to use some algebra. So if I said, let's call it x. So, if it was the first term, it'd be 2 times 1, second term 2 times 2, third term 2 times 3, fourth term 2 times 4. So the nth term, or the x term, or whatever variable you want to use, then you can go, right, it's 2 times something. You could write x, but in general we use n. We call it like the general term or the nth term. It's the general rule. For any term. In this particular situation, it's just 2n, 2 times whatever term that you have. So you can always look at a pattern and see if you can figure out the general term. So once you recognize if it's linear or not, usually the next job is to figure out, so is that one linear? Okay, yes, it is linear, but it's not as obvious for this one or the first one that I showed you as to what the common, the general term is. So for linear or arithmetic, you can actually go to your log tables . And so arithmetic, and if you want the general term or the nth term, this is your formula. If you fill this in, you will get the general formula or the general term for this particular sequence or this particular sequence. So it says exactly what the A is. So A in this is the first term of your sequence, and D is your common difference. So if you just fill that in, the nth term in this situation is A, which is 11, plus n minus 1 times the common difference, which is 7. And clean that up, that's 11 plus 7n minus 7, that's 4 plus 7n. That's your general term in this particular situation. So it's not as obvious or easy to come up with that one as it was to come up with some of them. Like that one was very easy. So if you want to, you can go to your log tables, that'll get you your general term. Let's just check if it works. If we were looking for the first term, instead of n, we'd be putting in 1. So 4 plus 7 times 1, that is 11. If you want to check for T2, the second term, it means instead of n, you'd be putting in a 2. So that'd be 4 plus 2 times 7, which is 18. So that one definitely works. And again, A plus n minus 1 times D will get me the general term or the general rule for this particular pattern. And that gives me 2 minus 3n plus 3, which gives me 5 minus 3n. That's the general term for this particular pattern. You can check it out if you want. So if I was looking for the first term, instead of n, I'd put in a 1. So that's 5 minus 3 times 1, which is 2. This just allows me to get any term I want. So if I want the 100 term, instead of n, I'm going to put in 100. So that's 5 minus 300, so minus 295. That's the 100 term in this particular sequence here.